Hi there, I just wanted to give you an explanation on your number 3 and 4. They're similar to each other, so when they're asking for the GCF, what you can think about is how many x's do they have in common, right? That's what that C stands for. So when we're looking, oops, that should be a 9, sorry. When we're looking at our two terms here, you can visualize them broken up, or you can look at the exponents and say, okay, like what is the least number that they have in common, or the most number that they have in common? So if we're looking at x squared, you can break it up into x times x. And if you're looking at x to the 9th, you can break that up into x times x, 4, 5, 6, 7, 8, 9. Okay, so that's really what exponents means. It means that I have 9 of these x's, or I have 2 of the x's. So your goal is to see how many do they have in common. So they at least have 1 in common. They have 2 in common, but they don't have anything else. So what you could say is the GCF was x squared because you had 2 x's in common. Same idea over here. You can have your x squared, which is just x times x, x to the 5th. Same idea, but just now 5 times. So again, you want to see how many do they have in common. So they have 1 x in common. They have 2 x's in common. They don't have anything else. So that's x times x. So the GCF over here is also similar. X times x, or x squared. So when you're looking at the exponents, a general idea is that whatever the least number of exponent is, that's the one that's going to be your GCF. So for instance, over here, our least number was 2. 9 was greater. That means I can take at most 2 out of each of them. Same over here. Our least was 2. Even though these have 5, we can only take 2 out of everything to make it equal.